Hey guys, hope everyone is doing well and welcome to my channel Math Coder. In this video, we'll be discussing a solution for unique parts in a grid using combinatorics. In this problem, we'll be given a matrix which is of order n cross n, and then we have to find all the possible paths which connect the start and the finish position. It is given that the start will always be the topmost left corner tile, and then this finish will always be the bottommost right corner tile. It is also given that we cannot retrace the paths, that is, we can just travel downwards or rightwards, and then we cannot travel left or upwards. That is, this is a valid path, while this isn't a valid path because we are retracing the path that is going upwards. So this is the problem statement. Now we will dive into the solution. Now I will illustrate this problem by taking a simple example of 3 cross 3 matrix. So basically we have to reach from this position to this position, right? So just by going by the trial and error method, we can go by this way or this way or like this. And this will be one of them. And then like this one. So for the 3 cross 3 matrix, there are totally 6 possible ways of going from this position to the end position. But how to compute these positions, number of positions? There are 2 approaches. One is DP, another one is combinatorics. So in this video we will just see about the combinatorics approach, and then we can see about the DP approach in the upcoming videos. So if you observe these diagrams carefully, every path will be composed of 2 rightward paths, rightward symbols, arrows, and then 2 downward arrows. Let's just take this one. We'll go down first and then rightwards, and then again down and then right again. If you see this one, we'll be going rightwards first and then 2 times downwards and then again rightwards. This one is down, right, and down. So can we just think of using permutation and combination for this problem right now? Because see, we have 4 different objects or 4 objects which we have to rearrange in a way so as to obtain different paths. So basically what I'm trying to say is, here in this problem we have 2 rightward and 2 downward arrows. Just imagine us putting them in an array of size 4. So different arrangement makes different paths. For example, if you put right here and then down, right, and a down, you'll be getting a path which looks similar to this one. Right, down, and a down. If you put like down, right, down, it will be like down, going down first, and then right, and a down. So different arrangements of these 4 arrows will give us all the positions for any order of matrix. So that's what this combinatorics approach is all about. Now we will see how to do this one. Now see, there are 4 arrows, among which 2 are identical and other 2 are identical. So in how many ways can we rearrange these 4 arrows? So this is basically 4 factorial ways, but 2 of them are identical with each other. So we will divide it by 2 factorial for this one, and then another 2 factorial for this one. So this is nothing but 24 divided by 4, which is 6, which is same as the one which we obtained here. So by generalizing it, if we are given a matrix of order n cross m, and then you'll be standing over here, which occupies 1 unit. So there will be totally n minus 1 downward moves, and then m minus 1 rightward moves. That is, we will have to move downwards n minus 1 times, and then rightwards m minus 1 times. So this is basically like the total moves that we have to do will be m minus 1 plus n minus 1, which is m plus n minus 2. So the permutation will be k factorial divided by m minus 1 factorial divided by n minus 1 factorial. K minus 1 is the total number of steps that we have. That is the total number of rightwards and then downward steps, and then this is the number of rightward and this is downwards. So if we just compute this value, then we will get the total number of steps, unique steps from the starting point to the ending point for any ordered matrix. But actually this method has some limitations, because basically we had to calculate the factorial of numbers. What if the factorial is so large that we cannot store it in any type? In C++, there are limitations to the values that can be stored. If we store more than that value, then overflow will occur, and then we will get values less than the real value or even in negative. For example, what I'm saying is, if you see the value of 10 factorial, then it is some 7-digit number. But if we see the value of 100, then it is about 157, which is basically, it has 158 digits in it. And then if you see the range of double, it is just like 15 digits. So we cannot store that much big values in C++. So this method will fail when we have huge values. For example, if the order is given in terms of 100, 200, then this method would absolutely fail. So we have to modify or think a little bit different to obtain the answer. So if we just see, what we were doing is we were summing up the steps and then we were taking the factorial. What if I say we have like 5 different moves, which or 3 down and then 2 rightwards? If you just take any one of these, like if you take the rightward moves and then find a way to put both the rightward moves in the array, then it is sure that these 3 positions will occupy the remaining blocks. What I'm saying is, if you just find the number of ways in which this right word can be allocated in the array, then we can easily say that these downward positions will take the remaining blocks. So if these two right words are allocated here and then here, then it is for sure that these downwards will take this one, and this one. And then as these arrows are identical, these 2 arrows can come in both of their positions, and it doesn't matter actually. So if you just place these 2 rightward arrows, the number of ways will be 5c2, because we just had to pick 2 positions from this 5 positions and then allocate them. We need not distribute them because they are identical. So if you just take 2 positions out of those 5 positions, The remaining 3 positions will definitely be occupied by the downward arrows, and those are also similar with each other, so we need not distribute them also. So if you just take an example, like we allocate the first and the last block for the rightward moves, so these down will definitely take these 3 positions. So it's nothing but going rightwards and then 3 downs and a right. So different combinations of this also will give all the positions, that is all the paths for an n crossed m matrix. The computation of this is very much easier than the calculation of factorials. Why? Because we just had to calculate the combination of combination of phi c2. We need not calculate the phi factorial separately. We just had to calculate the phi into 4 divided by 1 into 2. That's all. This can be achieved very easily. So be it any n cross m matrix, first we will find the number of steps that we have to take, that is n minus 1 downwards and m minus 1 rightwards, and then we will see which one of them is smaller. For example, here it was 2 and 3. We took 2 and then we try to distribute them in the array, and then the 3 downwards will occupy the remaining positions. If you see, phi c2 is also same as phi c3. It's a property of combinations. That is, NCR will be same as that of NC n minus r. So if you use this property, then phi c2 is same as that of phi c3. So if you just calculate the minimum value of n minus 1 and m minus 1, it is sufficient to know or arrive at the final answer. So let's just calculate the k value, which is the total number of steps that we have to take, which is nothing but m plus n minus 2. And then now if you see, we will do kc, the smaller value. Whatever the smaller value that we obtain over here is, let's just store in p, so kcp, that's all. So this kcp can be anything like kcn minus 1 or kc m minus 1. So what we are doing is basically just taking n minus 1 places from this k, and then allocating those places for the least number of arrows that we have. That's all. You're done with that one. So after this step, there is just allocating the least arrows, the spaces, then the large number of arrows will take their positions, and then the resulting will be the total path that we have. That's all. This is the method that we can do to easily find out the total number of steps. So in order to calculate this one, I will tell a better approach than calculating the factorials, which is like, if we have to find any factorial, let's just say phi c2, we need not do phi factorial divided by 2 factorial into 3 factorial. We just have to do phi into 4 divided by 1 into 2. So if we combine these phi and 1, just a minute. If we combine this phi and 1 and then 4 and 2, then our work is easily done. And then this will also not overflow like the previous method. So if we just go by a for loop, which starts with I equals to 0 and then ends when I becomes equal to the minimum value which we have told, like assigned to P here, we will store the result in res, and then we will multiply it to the total value, which is k minus I divided by I plus 1. So if you just see this one, so what it will do is first enter the loop, and then if the rest was initialized to 0, initialized to 1, it will start from 1, and then 1 into k. K is 5 in this sum, so 5 minus 0 divided by 0 plus 1, which is nothing but 5 by 1. So that's what we want over here. And then the next step, it will be 5 by 1 into this k minus I, right? So I will be 1 in this case, so 5 minus 1 divided by I plus 1 in the second run of the for loop, so it will be 2, which is nothing but 5 divided by 1 into 4 divided by 2. This is what 5C2 is. So if we use this method to calculate combinations, then it will be very easy, and then we will not obtain any overflows. Actually, I have implemented this logic and have written a code. Just a minute, I will take you to that one. So here, I'm not literally getting a matrix, I'm just getting the order of the matrix, which is enough for me to calculate the total number of moves. So I will pass it to the function, which is called path, and then I will calculate the total number of arrows that we have, the total number of arrows, and then I will calculate the minimum value among the m-1 and then n-1. If you have that, then it is easy to calculate the combination of this one. So this is nothing but the combination, that's all. So the total here is total, not k. Actually, I have used k in the examples, so it is total over here. So total minus I divided by I plus 1, and then I will run the loop till it achieves the value, which is k. So in order to check whether this code actually works or not, let's just copy it and then go to the browser and path, put the code, just give a trial run of the code, and then let's submit it. Yeah, in code accepted. So that's it for this video, guys. If you like the video, just give a thumbs up and subscribe to my channel. And don't forget to drop your thoughts in the comment section. Thank you, and meet you in the next video.